Hi, this is Dan. This is a chapters 4 through 6 solutions video for statistics fall of 2014. First question is a traditional kind of probability one. Use the OR principle or union. It says what's the probability that someone, if they randomly chose, is a woman or a regular smoker. So there's 555 women, so there's 555 out of 1156. Or regular smoker, 157 out of 1156. But how many of them have we counted twice? Well, these 86 right here have been counted twice, so we have to subtract them off. So it's the probability of A plus the probability minus the probability of A and B. So 54% is the probability we'd randomly pick someone out of those two categories. On the second one here, find the probability that they're a woman and an occasional smoker. So how many are both those things? Well, 48 are occasional and women, so 48 out of 156 is pretty straightforward. Randomly selected person is a man given they're an occasional smoker. So that's probably if A intersect B. So how many are both a man and occasional smoker? There they are, 50. But now it says given they're an occasional smoker. So we're only going to compare that 50 to the occasional smoker category. So that's going to be 50 out of 98. And then the kind of the flip of that one, what's the probability they're an occasional smoker given that he is a man? So again, how many are in both? Probably A and B. So it's still 50. But now I'm comparing it to the group of men because we know it's a man. So it's 50 out of 601. And the last one, what's the probability a random selected person is a non-smoker? So kind of bring you back to very straightforward. Non-smoker is 813 out of 1156. Number 2. You got 35% of the questions said their health was excellent. So what's probably that it was not excellent? So this is called the complement. 1 minus 0.35 is 0.65. And then what's probably they'd pick 2 people in a row that are not excellent. So that's 0.65 and 0.65. So it's a compound probability. Let's see here. Let me see if I can shrink this down a little bit. Move that over. Okay. This way. Alright, and the next one is find the probability that exactly 3 out of 10. So this is a binomial probability. So 10C3, that's all the different ways you could have 3 out of 10 reporting excellent health. So this is 10C3 is all the combinations that could happen, and then this is the probability of that event happening. 0.35 to the third, because we went 3 to say yes, and 0.65, 7 to say no, and that's a about 25% chance. And then what's the probability that when 10 adults are randomly selected, 3 or fewer, that means 3 would be fine, or 2 would be fine, or 1 or 0. So really we have to do this binomial probability for all of them. So there's 10C 0, 0.35 to the 0, 0.65 to the 10th. That means essentially nobody reported that they were excellent health, or all of them said they weren't. And then for 1, 2, and then here's already the calculation for 3. And if we add all those up, those 4 numbers together, we get about 51% chance that you would get 3 or fewer that are in excellent health. Number 3, just essentially it's asking, you got 15 books, how many groups of 6 could you make? So that's 15C6, because order does not matter. It says groups right there. And the other one is arrangement, so that means order does matter. So it's 15, it's permutation, so 16P6, which amps it up quite a bit. It's over 3,600,000. Number 4, 3 are defective, 22 are good. So what's probably you get 2 good ones in a row? It's 22 out of 25 that are good. And then again, if you replace it, again to pick a good one is 22 out of 25. It's an AND situation, so we multiply. So 77.44%. And then it says, what if you don't replace? So it's 22 out of 25, and then 21 out of 24. Just about the same, just a little bit lower percentage. Number 5. It says 52% graduate and get a job. What's the probability that you get at least one finds a job? So at least one, that means 1 or 2 or 3 or 4 or 5. So we could do all of those binomial probabilities and add them up, but a simpler way is just take 1 minus the opposite. So 1. So what we're trying to say is, okay, what's the opposite of at least 1? That would be nobody getting a job. So let's find the probability that nobody gets a job, which is here, 5C0. Nobody gets a job, 0.52 to the 0, 0.48 to the 5. And if we subtract that from 1, that adds up all the other probabilities combined. So that'd be 1 or 2 or 3 or 4 or 5 added up, and it's 97%, 0.9745. Number 6 is an expected value one. Policy costs $113. The probability they live is 0.9992, which means the probability they die is 0.0008. And what's the probability of them cashing out? Well, 0.0008 times 120,000 minus 113 leaves you 17. So that's actually $96. So for the person buying it, it's a negative $17. And then it says, how about from the perspective of the man? So that's negative 17 for the man, and then for the insurance company that would be a positive 17. So I was just looking for that distinction, that you realize it's a negative expected value for the policyholder and positive for the business. Number 7, expected value. So pretty much you take the probability of the event times what you get. So if you buy a lottery ticket, there's 1,000 tickets, so you got a 1 out of 1,000 chance. The prize is, if you win, $500, and then subtract off what it costs you to play. So essentially, on average, every dollar you spend, you're losing half it. It's like a 50-50 raffle. Now I said, hey, what if you get 6 tickets for $5? A couple ways you could do this. So I'm going to have 6 out of 1,000, and I still win $500, but it cost me $5 to play. Well, that's a net negative $2. Well, if you think about it, that's $2 on average I'm going to lose out of 5, which is about 0.4. So instead of, if you're going to think about it, and accepted some answers that did it per dollar, negative 0.4. So you're losing 40 cents for every dollar you spend, or $2 for every $5 you spend. It's the same thing. 8, again, you just multiply the probability. So rolling a die, it's 1 out of 6. I roll it 9 times. How many 2s show up? So 1 6 times 9 is, so I should average 1.5 2s. And then same thing here. A little tricky here is 80% are opposed. Find the average number would oppose. So 80% of 120 is 96. Just multiply that. Let's see, move this over just a bit, if I can. And I'm going to shrink that down a little bit so I can get on the page. All right. Number 10, and now we're looking at the normal distribution here. Draw the normal distribution, 138 in the middle. Essentially, we're trying to find the cutoff for the top 10% or the bottom 90%. And if you look in your Z table, 1.29 is about as close, is pretty darn close to 90th percent. I accepted 1.28 as well. And then we set up our Z score formula here. So Z, which is 1.29, equals X. We don't know which one that is, minus 138, which is the average, divided by the standard deviation. We do a little algebra here. Multiply both sides times 113.5, add 138. And so 155.45 is the 90th percentile for blood pressure. And then it says find the middle 90%. So we kind of draw this picture. It should help. Middle 90% leaves 5% in each tail. So it's 1.64 each way. So it's the same problem as before, except we have a different z-score. So we're going to use negative 1.64 and positive 1.64. Do the same math. Multiply by 13.5, add 138. So that's 115.86 on the low end and 160.4. So 90% of the time the blood pressure should be between there. Number 11, we're just going to calculate again another z-score here. For each one. So a 28 is their score with an average of 21, standard deviation of 4.9. So that's a 1.43 z-score. 1.43 standard deviations above normal. So say, okay, what's the equivalent score on this other test? Well, we know it's got to have the same z-score, and we know the average is 69, new standard deviation. So we, again, cross multiply by 11.5, add 69, and we get a test score of 85.43 is the equivalent score. And 12, average snowfall is 93. What's the probability that it's over 95.8? So that's actually shaded above, shade up here. So calculator z-score, it's 0.175 or 0.18 is fine. And if you look that up in your z-table, it's 0.5714, but we want the area to the right, so we subtracted from 1, which gives us 42, or about 43% of the time. And then the second part on this one is the same thing as the central limit theorem. Now we're looking at the average for 64 years. So we got to divide by the square root of 64, which now instead of 16 in the denominator, it's going to make this a 2. So a lot less spread in the data, which makes our z-score 1.4. 1 minus 0.9192 is 0.0808, so only an 8% chance that the average for 64 years would be above that. 13, we've given an average of 83, and so we're trying to find the probability of 85 or less, so we just find the z-score. It's 0.25, 0.5987. Pretty straightforward on that one. Now, second part, again, essential limit theorem. Now we have to divide by the sample size, the square root of the sample size, so that's going to give us 2 in the denominator, 2 in the numerator, so we get z-score of 1, and if you look that up, it's 0.84. So 84% of the time we'd have a group average of 16 students to be 85 or less. So that's it. Hope this video helps you prepare for an exam or get ready for the final, and talk to you later.